Here's problem 1110. A thin rod of mass m and length L is struck at one end by a ball of clay of mass little m, moving with speed v as shown in the figure. The ball sticks to the rod. After the collision, the angular momentum of the clay rod system about point A, the midpoint of the rod, is, well, even with this collision, one thing we know is that angular momentum will be conserved. So the initial angular momentum will equal the final angular momentum. And we do have an initial angular momentum here. It's all associated with the moving mass little m. As that mass is moving, even if it's moving in a straight line about our axis of consideration, which is A, it still has angular momentum. And its angular momentum is equal to mvr, where r is the shortest distance from its line of action to the point of rotation in this case. So our r is this distance right here from the line of action of the movement of mass m to our axis of rotation. So that angular momentum is equal to mvr. And in this case, that's equal to mv. R is equal to L divided by 2. So this would be L divided by 2. So that is our initial angular momentum. After the collision, we're going to have this rod, and it's going to have this mass on it, and the moment of inertia is going to be different. The moment of inertia is going to be the moment of inertia of the mass m plus the moment of inertia of the rod, and that would be equal to mr squared plus 1/12 ml squared. R squared being L divided by 2, so this would actually be equal to little m L divided by 2 squared plus 1/12 big M L squared. That's nice to know, but we don't actually have to know that. I just did that for future reference because usually that's what would be required in this kind of problem. But we're asked for what is the final angular momentum. And since the initial angular momentum equals the final angular momentum, the final angular momentum will equal the initial angular momentum, which is, as we determined, mv L divided by 2. So that is it right there. That is conservation of angular momentum, and that is our final angular momentum, mv L divided by 2.